Welcome back to the Historic Mathematics Academy, an inclusive organization founded on truth, where curiosity and engagement connect philosophically to encourage lifelong learning. We're glad you're here. We hope you'll enjoy today's lesson on volume and surface area with our wisest teachers, Socrates, Plato and Aristotle.
Hello again, I'm Aristotle. Last we were together we started our new unit on volume and surface area. As you may remember, this is a part of geometry concerned with questions of shape, size, position, and properties of space. And one of the most important aspects to volume and surface area are that the units of surface area are squared, and that the unit's volume is measured in a cube. As you experienced during our last lesson, these problems are more challenging than they appear. I recommend that when you are solving these problems, to be patient, to pay close attention to the details, and to stay organized with your mathematics. Also, during our last lesson we reviewed the volume and area formula sheet. We came to understand that this is to be your mathematical toolbox for calculating volume and surface area. Once again, here are the steps to use it. First, identify the shape you are trying to analyze. Second, determine if you are calculating surface area or volume. Thirdly, select the correct formula to use. Now, I'd like for you to continue practicing solving volume and surface problems, and to apply these formulas with my teacher, Plato.
Greetings. My name is Plato. I'm excited to continue teaching you about volume and surface area. Let's begin with this problem, calculating the surface area of this shape with the dimensions seen here. First, let's determine what shape this is and choose the correct formula from our formula sheet. You're right, this is a square-based pyramid and the correct formula is the corresponding equation found in the surface area column. This formula may seem complex, but with a little imagination, you'll see that it is much simpler than it appears. For instance, imagine unfolding this three-dimensional shape into a two-dimensional net, seen here. Notice the four triangular shapes that make up the four sides of the pyramid. These two-dimensional triangles are all identical. This is where the number 4 in the surface area equation, highlighted in blue, comes from. And you can better understand that the S variable essentially represents the height dimension of these two-dimensional triangles. And of course, the last term in our equation is the area of the base, which is a square. Now, let's write out this formula on a clean sheet of paper, paying close attention to the shape and dimensions we're analyzing. As you're aware, I believe it's wise to organize all the given information about this square-based pyramid, relating to the variables in our formula, on the side of your paper, like this. Notice how I include the units of each dimension provided. Because all of the units are the same, we can now transpose our numbers into our equation, like so. Next, I want you to see how I've separated the numbers from the corresponding units, to again help you better understand how the solution's units are calculated mathematically. Now you can better understand why the answer's surface area calculation is in units of centimeters squared, because, as you saw in our previous diagram, this solution is mathematically describing a two-dimensional calculation. Let's try another problem. First, let's determine what shape this is, and choose the correct formula from our formula sheet. You're right, this is a sphere. And the correct formula is the corresponding equation, found in the volume column. Once again, let's write out our correct formula on a clean sheet of paper, paying close attention to the dimension of the shape provided. Let me ask you an important question. Is the dimension shown on this shape the radius, which is required for this volume formula? That's right. It is not the radius. This dimension seen here is the diameter of the sphere. Therefore, the radius is half of this length. Again, Notice how I include the unit of this dimension of this shape, seen here. Now we can transpose our numbers into our equation like so. And we then carefully calculate the answer, one step at a time until we have our answer. Very good work. Now, I'd like for you to continue your volume and surface area lesson with my teacher Socrates.
Hello again, my friend. My name is Socrates. I'm glad to see you again. Let's continue practicing our math skills with this problem, seen here. Let's begin by determining what shape we are analyzing, and choose the correct formula from our formula sheet. Can you tell me what formula is the correct one? That's right, this is a cylinder. And the correct formula is the corresponding equation, found in the volume column here. Next, let's write out our correct formula on a new sheet of paper, with attention to the shape and dimensions we're analyzing. But, before we begin, notice that this particular cylinder has a hollow cylindrical center. We need to account for this calculating two volumes. First, we calculate the volume of a cylinder which has a radius of 2 meters. Then we subtract the volume of the hollow cylindrical center, which has a radius of 1 meter. Notice that for each of the two cylinder calculations the only difference is the radius measurement, which I have given the variables R1 for the large cylinder and R2 for the small cylinder. Next, let's organize all of our given variables related to our total volume equations like this. To simplify our calculation, because each cylinder, large and small, shares the same height and pi values, highlighted in blue, we can factor them out to show the difference of the two radii, seen here, highlighted in red. Now we transpose our measurements into our formula, like so. Carefully, calculating our answer, paying close attention to our units, to arrive at our answer seen here. Excellent work. You can see how being patient, having attention to detail, and staying organized with your work are helpful skills in your mathematics. I enjoyed working with you. Now, I would like for you to learn again from my greatest student, Plato.
Hello again. Let's attempt a more challenging problem together that appears simple, seen here. Referring to your formula sheet. Can you tell me what are the correct formulas to use for this shape? And ask yourself, how many shapes do you see in this picture? Excellent work. You're right, there are two shapes that make up this ice cream cone. One is of course the cone, which is the volume formula seen here. And the second is the half sphere, or hemisphere, which can be calculated using the equation seen here in the volume column. Next, let's take a moment to think about how to organize these two volume calculations. Considering the problem's dimensions, let's start by thinking about a sphere, and then multiplying it by 1/2, to obtain the volume of a hemisphere. This will be the ice cream at the top. Then, we'll add the volume of ice cream contained in the cone to this total volume formula, seen here below. Next, let's write out our total volume formula onto a new sheet of paper, with attention to the shape and dimensions we're analyzing. Specifically, can you tell me what the radius of the hemisphere and cone are? Very good. They are the same. They are both 5 centimeters. Let's again organize all the given information that relates to the variables in our formula like so. Now, as all of our measurement units are the same for this cone, we can confidently transpose our numerical dimensions into our equation for volume seen here. We then carefully multiply and add our terms together, step by step, paying attention to our units, to come to our answer, which as you can see is in centimeters cubed. I had a great time practicing these math skills together. On behalf of Socrates and Aristotle, it was a privilege to teach you, and we hope to see you at our Mathematics Academy soon.
We appreciate you being here. Please remember to stay safe, to get your rest, and to continue your lifelong learning. Take care.